where some of the users need a different set of applications. They're a one-off set of applications. Some of those applications, believe it or not, you have to have admin privileges in order to be able to run the application, or they have to have admin privileges to be able to install the application. Again, you have a user with admin privileges, the threat level on your system goes up exponentially. We also have other pieces of software, system-level software running on the machines in order to do things like full disk encryption and to be able to back up the desktops to prevent loss of information. Well, sure.
Are you going to A, define which kind of virtualization you're talking about at some point?
Yeah.
And B, define your scope within your environment. It sounds like you're aiming towards only desktops. Is that correct?
In this particular, for what we're doing here is just desktops. Our server infrastructure has been virtualized for a couple years now.
But you're not looking at mobile at all?
We'll get to that. Yeah, I'll talk a little bit to mobile in just a minute. Mobile turns out to be one of the issues that you have with virtual desktop infrastructure. Okay, how do you deal with the mobile guy, right? Okay, well, and I'll get to that just in a bit. And what was your first question? I'm sorry.
Defining what kind of virtualization.
Okay, yeah. Our presentation virtualization was basically Citrix presentation server. Okay, what we're talking about here is server-based virtualization, where it's server-based desktop virtualization. Yeah, well, like I said, we'll get to that. So in our virtual desktop infrastructure, in that environment, we basically have a single image that we maintain. So by maintaining a single image that gets streamed into the desktop, then we've eliminated the number of machines we have to remediate in terms of patching and so on and so forth. It also allows us to eliminate some of the one-off configurations that we've been dealing with. What leaves us with one image to patch. The OS patches go into a single instance, and then that instance actually gets streamed out to each of the virtual machines every time they reboot. We force the machines to reboot once a day. So, at the application level, in terms of dealing with applications, we've moved into application virtualization so that to stream the additional applications out to that people need out to their desktops. In other words, so the core application, the core virtual image will have Microsoft products on it, basically the Microsoft Office products on it, and some system-level software like virus management, those types of things. Everything else gets streamed out to the box as a virtual application. We do this using a tool called ThinApp. One thing about stuff you virtualize within ThinApp is it runs in user mode. Okay, it doesn't require enhanced privileges to run anything inside of a ThinApp virtualized application. Because we virtualize the application and stream just the application out to the user when they require its use, we can patch just that one application, and the next time the user goes to use the application, he's got the patched application. So in the morning, he could have a vulnerable version of Adobe. We get the patch, we patch it, he fires up Adobe again in the afternoon, and he's got a patched version. Reduce costs. Whether or not you reduce the cost here or not depends on how many of these things you deploy. If you're a small shop, if you've got, you're not going to see a huge amount of reduced costs. In fact, this will probably cost you more money to operate this way. In our environment, to refresh a fat client takes about 8 hours because of all the data, configuration settings, and whatnot that the users keep on their desktop. So we have to transfer all that data up to a server and then transfer it back down onto the new machine. With the thin client, refresh takes about 3 minutes. You come in with a new client, you unplug the old one, you plug the new one in. They can be in the middle of a session, doesn't make any difference. You can unplug the box, hook up the new box, they go right back into the existing session.
Generally, when you refresh a system, you're doing so because there's something that you need to get rid of on the old system. What you just described doesn't actually get rid of any of their state, so is it really an apples-to-apples comparison?
Well, in our instance, when we refresh a system, it's when we refresh a VDS box, it's primarily because it's broke. Okay, We've been using these virtual terminals now for, we've had some of them that we've used for as long as 8 years in our presentation virtualization scenario. So yeah, I mean, when we replace the thing, it's primarily just because we got to get rid of it. You know, it's broke, and so we throw it out, or we're installing maybe a new wireless client or something like that in it, and then we'll pull the old client out, toss it away, and put a new one in. So. We also tend to see a more consistent performance and reliability since the machines are all diskless with the gold image streamed to them. They always start up in an optimal state, so you eliminate all your registry clutter and file clutter that essentially would have a tendency to slow a system down over time. You also eliminate any the degradation associated with the DLL dependencies because you're not loading any new DLLs. Okay, when you run the virtualized apps, the DLLs associated with the virtualized apps stay within the virtualization sandbox. They don't go into the operating system. As far as grain, I mean, this is a big deal to some of the folks. Is are we really going to do anything with respect to reducing our energy costs? Fewer desktops reduce our power requirements. The thin clients are much more energy efficient than the desktops. We figure they consume about 90% less energy than a regular desktop. In our studies we've done, we get to the best energy efficiency out of 2 ESX servers when we get to about 200 users per server, or 100 users on each server. That improves gradually, and we hit a plateau at about 1,000 users, at which point in time we figure we're saving about 73% of the energy that we would normally be spending if we were doing fat client desktops. Over 4 years, that turns out to be about 23% savings. If you throw in the air conditioning costs in the data center, it actually moves up to 43%. So, all right, pardon?
Somebody sneezed.
Okay. So we started this out in 2006. We did an analysis of our existing setup and decided whether or not we could try to use the Citrix desktop environment to replace the various user groups. We looked primarily at task workers and knowledge workers. We also looked at high-end graphics users, but because of the requirements for multimedia and audio, 3D types things, we basically said we can't deal with the high-end graphics user at this point. Citrix turned out to be the best solution at that point in time, but neither the Citrix or any of the other server-based computing solutions we looked at would deal with all of our multimedia requirements, nor would they deal with the collaboration tool we were looking at the time. So even given those types of things, we decided we'd go ahead and evaluate Citrix as a potential solution. During that same time, a small company called Provision Networks, which now belongs to Quest, started pushing forward the idea of going to a virtual machine-based virtualization solution. And we looked at that, and at the time it looked like a good idea, but it wasn't where we wanted to be. In 2007, the first generation of products came out from VMware, Citrix Desktop Server version 1, and VMware released their first version of View. They just weren't any good. They didn't work. Even Citrix said, "This is not, here's a product, but it's not going to be what you're looking for." So we kept at it. 2008, we got the second generation of topics of products. Citrix Zen Desktop 2 came out. We looked at it. It wasn't actually, quite frankly, didn't do much better than what we were doing, what we could do with Provision Network stuff, but it was a major improvement. It was also the point in time when we could actually run everything from a single image, which was very important for what we were trying to do. In the fall of 2008, the Citrix Zen Desktop 2.1, we implemented that. That's where we learned that the Citrix Zen Server hypervisor had some stability issues and some limitations, and we decided we'd just go ahead and go with ESX at the time. We were also at this point working very closely with Wise in the development of their TCX protocol, which was going to be necessary to do multimedia redirection and USB redirection. So, in 2009, we felt comfortable enough to